Hi everyone, welcome back to the channel. In today's video, we are going to learn how to reduce and control the percentage heat loss due to incomplete combustion in a boiler system. This is a crucial topic for improving boiler efficiency and saving energy costs, especially in power plants and industrial facilities. Here's what we'll cover in this session. The first topic is why heat loss occurs in a boiler. Next, the second topic is, what is the percentage heat loss due to incomplete combustion? Next, the third topic is, ranges of the percentage heat loss due to incomplete combustion. And finally, the fourth topic is, how to reduce the percentage heat loss due to incomplete combustion. We will cover the above topics in the upcoming slides. Next, we will learn and understand the why heat loss occurs in a boiler. When a boiler burns fuel to generate heat, not all of the energy is used efficiently. Some of the heat is inevitably lost during the process. A boiler burns fuel to generate heat, which is then used to produce steam or hot water. However, not all of the heat released from the fuel is transferred to the water. Some of the heat is inevitably lost for various reasons. Please refer to the picture below for a better understanding. Next, we will learn and understand what is the percentage heat loss due to incomplete combustion in a boiler. The percentage heat loss due to incomplete combustion in a boiler or furnace. Incomplete combustion occurs when the carbon in the fuel is not fully oxidized to CO2. Instead, some portion of it forms CO, which still contains usable energy. This loss reduces the overall efficiency of the combustion process. Next, we will learn and understand the ranges of percentage heat loss due to incomplete combustion in a boiler. In coal fuel, its percentage of the heat losses ranges from 1% to 4%. In oil fuel, its percentage of the heat losses ranges from 0.2% to 1%. In biomass fuel, its percentage of the heat losses ranges from 1% to 3.5%. Even small percentages can cause significant energy loss over time. These losses don't contribute to steam generation but still consume fuel energy. Next, we will learn and understand how to reduce, control the heat loss due to incomplete combustion in a boiler. Below are the recommended strategies to reduce the percentage heat loss due to incomplete combustion in boilers. The first recommendation, to reduce the heat loss. To maintain proper air-fuel ratio. Ensure proper air-fuel ratio. Too little air causes incomplete combustion, it leads to the CO formation. Too much air increases dry flue gas losses. Use oxygen, O2, sensors or flue gas analyzers to monitor and maintain optimal ratio. The second recommendation, to reduce the heat loss. Keep proper burner settings. Burners must be clean, aligned, and regularly maintained. Ensure uniform fuel-air mixing for efficient burning. The third recommendation, to reduce the heat loss. Monitor the flue gas composition. Continuously track CO, CO2, and O2 levels. Use flue gas analyzers to measure CO, CO2, and O2 levels. High CO levels indicate incomplete combustion. Take immediate corrective action. Next, we will learn and understand how to reduce, control the heat loss due to incomplete combustion in a boiler. Below are the recommended strategies to reduce the percentage heat loss due to incomplete combustion in boilers. The fourth recommendation, to reduce the heat loss, use good quality fuel. Choose fuel that is low in ash and moisture, and uniform in size. Dry and graded fuel helps maintain stable combustion. The fifth recommendation, to reduce the heat loss. Maintain proper furnace temperature. Low temperatures can lead to quenching and formation of CO. Keep the combustion chamber temperature is high enough to support full combustion. The sixth recommendation, to reduce the heat loss. Install automated combustion control systems. Install automatic combustion control systems to adjust air-fuel ratio in real time. Integrate with O2, CO sensors for real-time control. The seventh recommendation, to reduce the heat loss. Prevent fuel slagging and clinker formation. These can be smoother the combustion zones. Regular cleaning avoids interference with flame stability. Next, we will learn and understand how to reduce, control the heat loss due to incomplete combustion in a boiler. Below are the recommended strategies to reduce the percentage heat loss due to incomplete combustion in boilers. The 8 recommendations to reduce the heat loss, regular inspection and maintenance. Clean and inspect the below components in the boiler: burners, furnace internals, fuel injectors, nozzles, air preheaters. The 9th recommendation to reduce the heat loss, preheat combustion air. Install economizers or air preheaters to raise the temperature of combustion air. Hot air supports more complete and efficient combustion. The 10th recommendation to reduce the heat loss, avoid overloading. Overloaded boilers lead to incomplete combustion. Always operate the boilers within their design capacity. Next, we summarize, and the conclusion of this video is: let's quickly recap what we learned. We learned why heat loss happens. We understood how incomplete combustion contributes to that loss. We explored typical ranges of this heat loss. And most importantly, we discovered 10 smart ways to reduce it. We hope you found this video helpful and now have a better understanding of how to reduce the heat loss due to incomplete combustion. If you enjoyed this video, don't forget to like, subscribe, and share it with your colleagues and friends. Hit the bell icon to stay updated with more tutorials videos. Thanks for watching and see you in the next video.